Okay, here's the material for week 3. So we have one more lesson. It's actually very short, even though it's 2 sections. It's really a review lesson, a review day with a review set homework test. And then what we were going to do this week, Thursday and Friday, were just 2 Venn diagram lessons that go with the IB test. So there's my email again. If you need to ask for any questions, more than happy to help. All right. So like I said, we have one more lesson left. Technically it's 2 sections, but we're going to put them both together, and really it's mostly a review. A couple little things. Interpolation and extrapolation. We use that when we are making predictions based on our data. Let's just make a graph first. So let's just say, whatever, here's our data. Doesn't matter what it's for. The smallest value on the x is called the lower pole. The biggest x value would be called the upper pole. If we make any guesses between the poles, that's called an interpolation data point. So like if we have our, say we got a best fit line like that, and we want to predict this value right here, which is between the poles, that would be an interpolation guess. Anything outside the poles, so if I want to predict what happens outside this pole or outside this pole, that would be an extrapolation. Those are not as reliable because we don't know for sure if the trend is going to continue. So answers might not be reliable. For example, when I sell pizza, if I buy 2 pizzas, I make this much money. If I buy 3 pizzas, I make this much money. 4 pizzas, 5 pizzas, 6 pizzas. But there is a point where this is going to start coming back down. If I buy 50 pizzas, I'm not going to sell all those and I would lose money. So that's where it's not reliable when making a guess outside the data point. All right, so let's do an example. Distance from school, and they'll call that the x value, and we'll put this in kilometers, and time traveled. That's the y. Normally time is your x-axis, but in this case the distance is fixed. We don't really need to know that because all this would be given, but normally time is the x, but this is a case where it's not. I have 9 data points. Most of them have decimals. So that's 7.2. The y values do not have decimals. Actually, I think I'll just write the numbers going across first. 13, that's I think the only one that does not have a decimal. 9.9, 12.2, 19.6, 6.1, and 23.1. And the y values 13, 19, 2, 25, 27, 41, 15, and 53. All right, so here's our data, and we're going to use our graphing calculator to get most, if not all, of these answers. Letter A, we're going to graph it. We don't need a graphing calculator for this one, but I know for some of the other ones it's good to have it, so I'll just put it all in right now. So we go to Stat, Enter, clear out any data that's in there already. 7.2, 4.5, 13, 1.3, 9.9, 12.2, 19.6, 6.1, and 23.1. The y values are 17, 13, 29, 2, 25, 27, 41, 15, and 53. We could check it. This is not vital that you do this, but you could turn your stat plot on by going second y equals. Turn the stat plot on. Make sure your window is good. I'd probably go 0 to, what's the biggest number? 23.1, so whatever, 25. And then the y, the biggest number was 53, so I'll just go to 60. And that can show it to us, but obviously that's not going to help us graph it specifically, but we will use the graphing calculator in a little bit. All right, so really we almost do A by hand. Put our labels on there. Distance from school in kilometers. That's the x-axis, the y-axis. Time traveled in minutes. Biggest number is 23, so I'll go by whatever, 5. 5, 10, 15, 20, 25. Could have went by other numbers. Try to get 6 to 12 marks. That's 6 right there, including the 0. Biggest number is 53. I'll go by tens. 10, 20, 30, 40, 50, 60. And then we plot the points. 7.2, comma 17, 4.5, comma 13, 13, comma 29, 1.3, comma 2, 9.9, comma 25, 12.2, comma 27, 19.6, comma 41, 6.1, comma 15, and 23.1, comma 53. So doesn't look as good as the graphing calculator, but good enough. All right. Letter B, we want to find what is called the mean point. And all that is the mean of x, comma, mean of y. Now, since we have this all in here, we could just grab that stat calc pretty sure it should be under one variable data. There's the mean of x, 10.8. Now the mean of y, I think we got to change. Yeah, we got to change the first thing. We go back to stat calc one variable. And where it says list, we got to change that to L2. And now it'll calculate that. There's the Y value, 24.7. Now I'm just curious. I'm not sure if this will work, but I'm just going to go back and change it back to L1. I don't think it's under second two variable, but let me look. Actually, I think it is. Yep, it actually was there. So it's actually quicker to do what I just said. So I'll just show that again. So you go stat, calc. Instead of going one variable, we are talking about two variables, so why not go to two variable then? Make sure you got L1 and L2. And there's your mean of X, and there's your mean of Y. All right. Letter C. Let's find R, find and interpret R. That's the Pearson's correlation coefficient. So here again we go stat, calculate, linear regression is 4. Make sure you got L1 and L2. And there's our R, 0.993. Since that's bigger than 0.95, or it's between 0.95 and 0.999, we say that's a very strong positive correlation. Letter D, let's just put that over here. We'll say write the equation. Again, the equation we can get right from the graphing calculator. It's on the same screen. Put that over here. There we go. The A is 2.15 or 16, I should say, when we round. So 2.16x, and the y-intercept is 1.42 plus 1.42. All right. Last question here. Actually, it's a two-part question, I think. Pam lives 15 kilometers from school. Estimate how long it will take to get to school. And is the answer reliable? Oh, I missed something here. This actually is important. Estimate using equation. So the other day or last week we were using the graph. So if we were using the graph, we draw the dotted lines and stuff. But when using the equation, okay, we got to use the equation. So we need to use this equation right here. 15 kilometers, again, kilometers is my x, so I'm going to plug that in for x and then get our answer. There's a couple ways you can do it, but you can just go 2.16 times 15 plus 1.42, 33.82. Now we do want to round that to 3 significant figures. So even though it terminated on the calculator, remember this was a rounded equation to begin with. So we do have to round that to 3 significant figures. Now IB is pretty lenient on taking the answer 33 or 34, but they will not take the 33.82. That's the first part. Is it reliable? The correlation says that it is, all right? So the correlation is very strong, but if we look at 15 kilometers, whoops, I was thinking this was a different example. I was thinking this was an extrapolation point. So both things have to be true. It has to be at least strong, and it has to be an interpolation. So correlation is very strong, so that's good. And it is an interpolation point. Because 15 is inside the poles. So since it's both, again, for the correlation just needs to be strong. All right, so the correlation needs to be strong, and it needs to be an interpolation point. If both of those are true, therefore, answer is reliable. If either one is not true, or if either one does not occur, it is not reliable. I think on the test, one of them wasn't. All right, so that's what I was getting confused with. All right, that's that's both sections right there. So that's done. Here's the review set, the topics that are on the test. Plot the mean point, best fit line, estimate value, find correlations, 3 formulas that we learned this chapter, substitution and estimation, plot data on a calculator, interpolation and extrapolation points. Here comes the test. Again, probably need to pause the video to get everything down here. So there's page 1. There's page 2. So all of that is one problem. Here's a matching. Here's a problem where you use some formulas or formula problems. More formula, so a lot of formula problems. Oh, make sure you got time there. See that? A lot of these problems are similar. Some of them could be done a few different ways. And here comes the answers. Again, you can pause the video to get the answers down. Again, this is an estimate. Doesn't have to be that answer, but should be pretty close. Could have multiple answers for that. for some of these, you could have multiple answers. Yeah, so here's one strong correlation, but it was an extrapolation point. All right, so that was the test. Now, Thursday and Friday would have been just lessons more for people taking the IB test, but this would be on either IB test, the math studies or the calculus one. So we're going to spend 2 days on Venn diagrams. Some of this relates to truth tables, which I do believe we did already. We have a few operations. Actually, I could write that down. Basic operations. And I think these should be familiar. The U or the N or upside down U is and. The U is or. Squiggly line is a not symbol. Now they could use a V or upside down V. Sometimes I've seen, let's see, it's like this. Yeah, so they all mean the same there. All right, so let's just do a bunch of examples. What we're going to be doing, is drawing a bunch of examples here. If there are 2 letters, there is going to be 2 circles. Label them A and B. On the IB test, that's usually all drawn for you. Sometimes they'll put a little U here. That just stands for the universal set. Don't really need to know that here. But I guess on the next lesson we do universal set. That's like the total number. All right, so when we draw, we are basically shading. So we want to shade where it's A and B. So it has to be in both. All right, the place where it is both A and B is in the middle. When you have an and statement with 2 circles, 1 out of 4 things are going to get shaded. So with an and statement, 1 out of 4 regions will always get shaded. If it's an or statement, what I always like to say is treat them separately. Treat as 2 separate problems. This one isn't real challenging, but still let's get used to the concept. So if I just look at the first one, covering up the second one, I want to shade where it is A. All right, now A would be in these 2 regions. So I shade all of A. And then I do the second part, cover up the first part. I want to shade where it's all of B. Okay, that would be in here, and that part already is shaded in. So if it's an or statement, 3 out of 4 regions get shaded. And then you probably wouldn't see this problem, but just so we understand what this means. Not A, when we put the A on the inside, that just means shade where it's not A. So that would be on the outside. We don't need to get every little speck, but that's good enough. All right. None of those would probably be on the IB test. They would make them a little bit more complicated, like the following. We want to shade where it's A and not B. The first thing I would do in all these problems is figure out, is it an and statement or an or statement? All right, this is an and statement, which means they both need to be true, and I know that only 1 out of 4 regions gets shaded in. So it has to be inside of A. Let me just put some numbers in here. You don't have to put the numbers in, but it makes it a little easier to teach. So it has to be inside of A, which means, okay, it can only be 1 or 2. And it has to be outside of B. All right, well, 2 is inside of B. So the only one that is inside of A, but outside of B is right here, section 1. And like we said, only 1 of the 4 regions are going to get shaded. That's it. Not A or B. So again, the first thing we do is figure out what type of problem. It's an or statement. So this is where people get a little confused. Again, I would treat them as 2 separate problems. So I'm going to cover up this second part. Let me put those numbers in again. Again, you don't have to put the numbers in, but they may help. Where is it not A? Well, not A would be region 3 and 4. So I'm going to shade in 3 and 4. I don't care what it says over there, because in or, only 1 of the 2 things need to be true. So 3 and 4 get shaded in. Now I lost my letters. I can just put those back in there. Now I do the other one. I want to shade where it is B. Well, 2 is B. And here's where people get confused. They're like, well, wait, you just shaded in part of A. Well, this is an or statement, and only 1 of the 2 need to be true. And we also said that 3 out of 4 regions get shaded in. So there's the 3 out of 4 regions that got shaded in. Actually, I need a little more room for these last 2. Now let's do one that has 3 letters. It doesn't matter how you draw the 3 circles as long as they all overlap each other. I usually draw 2 at the top and 1 at the bottom, but you could draw 2 at the bottom, 1 at the top. So as long as you intersect, and there should be 8 regions. Not should be, there has to be. All right, again, you don't have to put these numbers in, but it makes it easier for me to teach it. Again, the first thing you want to do is figure out if it's an and or statement. Now, technically it's both, but if you treat the parentheses as one variable, so just pretend this is like a B or something like that, this is an or statement. So it's not A or something else. So or means treat them separately, and if either one is true, you're going to shade it. So I'm going to cover up this, and I'm going to shade where it's not A. Well, that's 4 different regions. That's regions 3, 6, 7, and 8. So no matter what the rest of it says, those 4 have to get shaded in. Does not matter what else is said. All right. So 3 gets shaded in, 6 gets shaded in, 7 gets shaded in, and 8 gets shaded in. All right. Now I look at the second part. Where is it B and not C? So both of these got to be true. So inside of B and outside of C. That's not too many more spots. The only other one that's like that is number 2. So if you have or with an and inside the parentheses, 5 of the 8 are going to get shaded. Don't need to know it, but I think that's good to know. Let's try one more. This one gives people even more trouble. This is the one I would see most people most likely to get wrong. So again, we draw the three circles, A, B, C. Again, we want to figure out what type of problem it is. Again, I treat this like one big variable. So if I treat that as one variable, this is an AND statement, which means they both need to be true. Again, I'm just putting the numbers in to help me teach it. I don't think it really helps you do the problem, so you don't have to do that, but you can if you want to follow along with how I'm doing it. So it has to be an A and something else. So it has to be an A. So right off the bat, if it has to be an A, it can't be 3, 6, 7, and 8. There is zero chance I'm going to shade in any of those four. It doesn't matter what's said here. It had to be an A. So right now I'm already down to 4 regions. All right, so I'm only looking at 1, 2, 4, and 5 now. Now I'm going to look at the second part. It's in not B or C. So again, I'm only looking at 1, 2, 4, and 5. So or means either one needs to be true inside the parentheses. So the 2 here and C get shaded in, and not B would be 1. So it had to be an A, so all 3 of these are an A. And then it had to be one of these 2 in the parentheses. If you have an AND statement with an OR in parentheses, it'll always be 3 out of 8 regions getting shaded in. As long as we're talking about 3 letters. All right, so that is Thursday's lesson. Like I said, there is no homework. I did have worksheets, but I wasn't going to give them out anyways. I didn't bring them home, so no homework for that. And then Friday, again, we'll do more Venn diagrams, but today we're not, or this lesson we are not shading. We're using numbers. So we're going to go right to a problem. At this small school, we have, let's not abbreviate, we have 50 student athletes. So that means all 50 of these people are out for a sport. And this is a small school that only offers 2 sports. Football, so 38 played football and 20 played basketball. Make a Venn diagram. All right, so again, we have 2 circles. We can label them A and B, or it might just be better to label them F and B. Here's where I should have made this bigger, the universal set. There are 50, so the universal set is 50. Now, if you add 38 and 20 together, that's 58. Well, there's only 50 people. So some